All right, here's where I think we left off in section 5.4. We said f of x equals e to the x is the inverse of g of x equals ln x. And from there, we proved some algebra properties. We proved things like the domain and the range of e to the x, and we proved things like e to the x was increasing and concave up, and we looked at its graph. And we did some stuff with derivatives. We found out that the derivative of e to the x was e to the x. And using the chain rule then, if g of x is e to some other function, then the derivative, according to the chain rule, would be h prime of x e to the hx. And I think we did a bunch of examples with product rule, quotient rule, finding minimums and maximums, that kind of stuff last time. And we also talked very briefly about the integral of e to the x is e to the x. All right, but I don't think we've done any integration examples. So we need to do some integration examples today. So I'll steal a few out of the book here. The integral of e to the square root of x divided by the square root of x dx. Any good ideas on how you would integrate that? I'll give you a hint. The u substitution problem. U is? In most cases, when you're dealing with e's, the u is going to be the thing in your exponent. Not always, but quite often. So I'm going to try that. U is the square root of x, which is also the same as x to the 1/2. I differentiate. I get du is 1/2 x to the negative 1/2 dx, which is 1/2 times 1 over square root of x dx, because the negative power drops the x to the bottom. The 1/2 power is the square root. That's very helpful. Why is that very helpful? Because I want a square root on the bottom to match that one. So the only thing I'm missing is the 1/2. So I'll sneak a 1/2 right in there. Balance it off with a 2. Integral of e to the u du with that 2 out front. What's the integral of e to the u? E to the u. 2e to the u plus c. Final answer, 2e to the square root of x plus c. Questions on that one?
Is the square root of x in the bottom of the denominator, is that not u to the negative?
Notice that in my du, I had a square root of x on bottom, and in my problem, I needed a square root of x on bottom. So this 1 over square root of x dx is this square root of x on bottom dx.
Yeah, but like, what isn't it? Could that be like substituted like even before messing with the du stuff, just putting like a u in the.
All right, I see what you're saying. The answer is yes, but it's going to cause problems. So what you're saying is, I could write this as integral of e to the u over u, because square root of x is u after all. But then I still got to get rid of this dx. And so here's my dx. What am I going to have to do? I think I'm going to have to write that dx is 2 square root of x du. So I multiplied by 2, multiplied by that square root of x. And then what are you going to do with that square root of x? Call it u again. So that's 2u du. And so I replace my dx with my 2u du. And I'm right back at the same spot, aren't I? Because that u reduces with that u at the same time. So you could do it that way. But you generally, we kind of want to have to avoid that double substitution type deal if we can. But yes, it would work. Other questions? All right, let's try a couple more. Integral. Of e to the x, square root of 1 minus e to the x, dx. Any thoughts on that one?
U equals 1 minus e to the x.
Yeah, in general, if you have a square root with something more than just an x under there, use that thing. U equals 1 minus e to the x. And I think that's going to work because du is negative e to the x dx. And we have the e to the x dx out there. I need to sneak in a minus sign, which means I need to balance it with a minus sign. So that was a direct u substitution. Negative integral u to the 1/2 du. Negative 2/3 u to the 3/2 plus c. Final answer, negative 2/3. 1 minus e to the x to the 3/2 plus c. Questions on that? All right, one more of these. How about the integral from 0 to the square root of 2. That's promising already, isn't it? Square roots for numbers. X e to the negative x squared over 2 dx. What's a good beginning? U sub where u is the exponent. That's going to happen quite often. So u is negative x squared over 2. That works out pretty well because du is going to be negative x dx. All right, so kind of the same deal. I need to throw a minus sign in there to make my negative x dx. Balance it out with a minus sign there. This becomes the integral. I've got a minus sign out front. The negative x dx, all that became du. The e to that power, that became e to the u. And here's something I'm still seeing on some of the quizzes and things. People are not changing their bounds of integration. You've got to change your numbers. 0 to 1. Close. 0 to negative 1. Because if I plug 0 in, when x is 0, I plug 0 in, I do get 0. When I plug square root of 2 in, square root of 2 squared is 2. 2 divided by 2 is 1, but then I've got a minus. So it should be 0 to negative 1.
Switching over the negative?
Yes.
Is there still a negative for the e too?
No. This negative right here?
Oh, because that was part of the du.
That's right. That negative got taken care of with that negative x dx. Yes. Flip the integral to get rid of that minus sign and put the smaller number on bottom. Okay. Integral from -1 to 0 of e to the u du. What's the antiderivative of e to the u? E to the u. Evaluated at -1 and 0. And then I see some people changing their numbers, and then they get to here and they plug their x's back in. The whole idea behind changing the numbers is then you don't have to plug your x's back in, you just plug these numbers in. So you're making it much harder than it really needs to be. I plug in these numbers. I have e to the 0 minus e to the -1, but e to the 0 is a nice number. It's 1 minus e to the -1 would be my final answer there. Questions on that?
So you could not change the integrals and just plug in the end.
Yes. Yeah, we didn't have to get rid of this negative sign and flip. We could have just left it. We would have gotten the same answer. Other questions?